Good day. It's supposed to be super rowdy in here.
All right. Algebra 3, this is part 1 of our podcast. Hope you're having a great morning, great day today. Today I have some Algebra 3 students that are going to join us, and we're going to go through some of these problems. How we're going to do this is we have 2 study sessions that I'm going to podcast, the first of which we'll start on Chapter P, and we'll kind of walk our way through all of these problems. And then tomorrow at about 1:30 to 3, we'll also have another podcast that we'll do as well for the final. Also tonight, remember that we have a movie starting at 7:30, as well as a study session at the Rustic Couch from 5 to 7. Also come and check out some baseball today, right after school, and as JC takes on Lovett and hopefully dominates today. So a little shout out to the baseball team. All right, so with that being said, let's get underway. Right now I've got Mike and Riley in here. They're going to kind of help me out by asking questions, and we'll rock and roll. All right?
Yeah, I don't want to be.
Hey, Nate. I'm sorry. Nate, Luke, Ryan, Will, and Hans are all here as well. So they're with us. But they're kind of here because they have to. So we'll still give them the benefit of the doubt. All right. So with that being said, Mike and Riley, we're just going to have a conversation just with us here. We're going to start on Chapter P. Is that cool?
That's perfectly fine.
Because I know y'all are going to be here for other study sessions. The Rustic Couch tonight, I am not podcasting. So just giving you a heads up on that. All right. Would it be easiest just to start on Chapter P and just kind of do one of each example?
Please.
Kind of walking through?
Yes.
Okay. So what we'll do is we'll start, let's do numbers. I'll say, hey, do we have any questions on 1 to 3? If neither of you have questions on 1 to 3, what's up, Basil? Basil's in the house. Good to see you. Basil, it's a miracle, is here to this morning. Love it. All right, so Basil, I'm actually podcasting these to be. You could watch these later on. We're going to start on Chapter P if that's okay. And what we'll do is I'll just say, hey, do we have a question on numbers 1 through 3? If we do, we'll do one example, and then we'll kind of keep going from there. And then we'll go as far as we can up until about 10:15. Okay? All right, so I'll say again? I do, yeah, but a lot of them are juniors. A lot of juniors in here, so you'll see. So like my next class, I have 0 juniors, and then the following class I have Davis, and that's it. So yeah, I don't really have a ton. Great weekend, Nate. Appreciate you, man. All right, so numbers 1 through 3. Do y'all have the review there? All right, do we need to do one with numbers 1 through 3?
Can we do 2?
Let's do number 2. Let's do it. All right, now on this one, these ones are, I always call, ones like numbers 1 through 3 are ones that you just don't want to miss. On the exam is very similar to what you'll see through this review. And this really should be 7 plus 3. I apologize. I know it looks like a divide sign, but the way that it was put in there, it should be a plus. It got kind of cut off.
Answer my question.
This is number 2. Number 2. All right, so what's the first part of the process in solving this problem?
Do the parentheses.
Yeah, we'll do the parentheses, kind of top side, right? So what would we get here?
2, 4.
Good, plus?
9.
4 plus 9, good. And so, again, I've got to continue in here, like Basil said, to get what?
5. 11.
14.
13. Good. All right. You will also have your calculator for the whole exam.
Really?
Yes.
Wow.
Yes.
Okay.
Okay.
Thank you.
All right. I expect good gifts. That's all I expect.
Is this
We bring a note card too.
No card. I'm going to give you our formulas will be on there. So you'll have all formulas you need.
Is this for a grade? This review, did you make it for grade?
Yes. I think I said that. Just make sure you bring that to the final. It's going to be like a review, what we normally do with a review there. Okay. Can't do bonus. Can't do
No,
bonus.
not on the exam, but just like we replace like another grade.
I can't do that. We could talk later on that. We'll talk off record. Sound good? All right. So on the top, let's do the top first. Now, what would we do first on the top side?
Now you have to do 3 times 5.
Actually, okay, so
No, you do the
yeah, it's
5 times. No, wait, am I saying?
Okay, so right now we have divide, multiply, and multiply, right?
Yeah.
Okay. In PEMDAS, what comes first, multiplying or dividing?
Parentheses, multiplication, division. Multiplication.
Here's the hint: multiplication and division go together. So they're like on the same level, like adding and subtracting, same level.
Wouldn't you have to do 5 times whatever's in the parentheses first?
That's what I'm saying. Right here we have divide, multiply, and multiply.
You can do it all in a row.
Yeah, we could do it, but what we do is if everything is on the same level, we go from left to right like a book. Okay? So what's 12 divided by 3?
4.
Good. So then I take that 4 and I multiply by 5 to get what?
20.
What's 20 times 13? This is all on the top here.
20, what?
Yeah, 20 times 13. You see how I get that? 260. Yep. So we got 260 on top. What about the bottom? What do we do first on the bottom?
36.
Yep. Good.
7 plus 3 is 10. 10 minus 36 is negative.
Negative 26. Good. So when I divide this, what would I get out? Good. Negative 10. Excellent. Okay. And that would be number 2. Would be number 2. Does that make sense on how I did the top? The tricky part is because everything's like once everything's on the same level, you got to go in order. That's it. Okay. But again, if it's on the same level, left to right, you'll be fine. Okay. All right. Let's go to the next one. The next level is from 4 to 7 or 4 to 6 rather. Is there one on there that we need? Do we need one of those? Yeah. Go ahead.
You take the outside number one's raised to it. You just are gonna multiply it like the x the negative fifth. You'd multiply negative 2 to the negative fifth, right?
Correct.
And then you add negative fifth to the negative third. Right?
Correct. I feel like I need to do one of these.
I don't know how to switch them.
Yeah, let's do 6. Could we do 6? Yeah, I will tell you this one right here probably from last year, one of the most missed problems on the final. And it's not because it's difficult because we've done a buttload of these, but at the same time, it can be kind of tricky. So let's check this one out. Now, the first thing I always do is I always go inside first. So if I simplify the inside, what would I get? Is it positive? My fault? Yeah, it's positive.
What number are we doing?
It's positive there. We'll do number 6. Number 6. So what do I do with?
You have to bring the 21 down.
Well, we can't bring this down. Let's divide it. Can we divide that? Because let's divide it with negative 21 and 7. Okay. So let's get negative 3. Be on the top, right? Because the larger number's on the top. So when I divide, it should be reduced to where negative 3 is on the top side. Okay. Now, let's simplify on the inside. So let's keep the x to the 4th on the top, y to the 9th on the top. But let's say I brought x to the 10th, y to the negative 3rd to the top as well. What happens with the 10 and the negative 3? Yeah, what's up, man?
When you divided by 7 and you had the x to the 4th, x to the 10th, you just subtracted x.
I haven't subtracted yet. Not yet. Some people can do that, and that's fine. Let's say that I brought these to the top to where I could simplify. What happens with x to the 10th when I bring it to the top? It'd be to the negative 10th. Very good. And Mike, you went in advance on that. That's right.
Now it would just be negative 6. X to the negative 6.
Good. Now I could combine the x to the 4th and x to the negative 10th. Remember, when I have x to the 4th times x to the negative 10th, I add these two together to where now I get x to the negative 6th, right? So I have negative 3, x to the negative 6th. Remember, y to the 9th I keep here, but what about y to the negative 3rd when I bring it? Yep, and it changes to a positive. Good, Hans. Good. Yep, and now I can say y to the 9th times y to the 3rd, which should be y to the 12th. Okay? Now, quick question. In this example, x to this negative 3, if I were to simplify this, now we still have the 3 here, but if I were to simplify this, does this negative 3 go to the bottom? Does this negative 3, would that go to the bottom of the fraction? Good. Because even though this 3 is negative, that does not tell me it goes at the bottom of a fraction, right? Bingo. Mike, you're right on. Only negative exponents push it to the bottom. So yes, this x to the negative 6 would go to the bottom. So if I made all of this positive, it would look like this. Negative third, or negative 3, y to the 12th, and x to the 6 would be on the bottom because I pushed that to the bottom because it was negative. Okay. And this is the answer until we have it to the third power, right? We haven't done that yet. Okay. So remember, the 3 will go to each part of these. So 1, 2, and 3, right? So what's negative 3 to the third? Negative 27, right? Because negative 3 times negative 3 times negative 3 is negative 27. Don't multiply those two. Remember, it's to a power, to that power of, okay? So that's why we have negative 27. Keep it on top. What about the y? What happens with the y here?
12 and 3 is like 30 something.
Good. Remember, we multiply to get 36. Good. And Riley, what would the bottom one turn into? Dun 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 dun.
216? Or am I wrong on that?
Well, what'd you multiply?
6.
Times? 6 times 3 is 216? What's 6 times 3?
18.
Yeah, you got it. You got it. Riley right now has her Waffle House here.
I have my
So
whole
she's still
house
trying
here,
to.
basically.
That's right.
All my
Yeah,
medicine, all
I know.
my-
I love it. I love it. Just make yourself at home. I love that.
Really.
I really do. I love that. All right. So with that being said, that's how we get that question. Does that make sense? There?
Yeah.
Okay. Good. So we've got 2 and we've got 6. Great. Are we good on those 2?
Yeah.
Perfect. Can we go to the number 7 to 9? What one on number 7 to 9 do you want me to do?
Any of them, I don't know how to do those.
Okay. Let's do the number 7. How about that?
Yeah, I do. So you just have to get the in the parentheses the same thing.
That's it. That's it. Well, when we say the same thing, all we're doing, it's like 3 separate problems, right? Remember with this, inside the square root, we're trying to get pairs, right? So let's do the easy one, 8. 9 square roots of 8 here. What are the 2 numbers when multiplied that give me 8? 4 and 2, right? Now, we can stop for just a second because we know that we have a perfect square here. What's our perfect square? 2, right? From 4. So if we brought a 2 to the outside, what would change? What would happen with that 9 square roots of 8?
Wait.
Good. Negative 18 square roots of 2. So let me backtrack. You see how this 8 right here is inside the square root? We're trying to find pairs from that. So
You
what's...
have to take 4 down to 2 and 2.
If you want to do that, that's fine. When I see that there's a perfect square there, I could take square root of 4 and bring a 2 to the outside.
How did you get negative 18?
So I get that. Because remember, I brought a 2 to the outside, correct?
Oh, and you had to multiply it and you just left it out.
Correct. This one was the one that was left over.
So you paired off 2 of the 2s, and then you took that lone one and you multiplied it.
No, the one that I take to the outside is when I have a pair, right? Remember, what's the square root of 9? 3, right? You just do that off the top of your head, but really what happened is, what are the factors of 9?
3,
1, 3.
Yeah, 1 and 9, but really 3 and 3, right? So is there a pair in 3 and 3? Yes, there is, right? Because there's 2 3s in square root of 9. So you bring 1 to the outside. That's why you get 3. Does that make sense? Now, this is just a little more complicated when we look at it. But, I mean, it's just the same pattern. When I have 2 2s or a pair of 2s, I bring 1 to the outside. And whatever's left over, I leave on the inside. Okay? Let's check out the let's go to this one. What 2 numbers multiplied get me 200? Yeah, we could just do 2 and 100, right? We could do other stuff, but 2 and 100. Is there a perfect square there?
No, but you can bring out a 2. You know,
Yeah, well, look at 100, right? What are the factors of 100? 10 and 10. Isn't that a perfect square?
But you're looking for pairs, right?
Correct. Yeah, that's a perfect square of 10, 10, right? So what do I bring to the outside?
Plus 10 root
What do I bring to the outside there?
10.
10, good. So now what do I do with 10 and 2? I multiply these together to get what? 20. And what do I leave on the inside? The 2, right? So 20 root 2 would end up being my answer for that middle part there. Does that make sense? We're good there? Perfect. All right, let's go to this next one, -3 square root of 162. What are the factors of 162 here? Is it 2 and what was it? 81? Okay, perfect. Mike, are you getting this right here?
I'd rather watch and then see how you did.
That's what I'm saying. I'm just pausing for a second. Do you understand how I got to this point?
Yes.
Okay, so I'm going to ask you a question. Is there a perfect square in 2 or 81?
You can do 9 and 9.
Perfect. So what happens when I know that this is 9 and 9, right? Knowing that this is a pair, what do I do with that 9?
Well, you did 2 and 81.
Multiply it by
Bingo. I bring 1 to the outside. I multiply by -3. So keep the 2 on the inside. Perfect. So what would that be for the outside? -27, and that's how you get your 3 there. Okay. Bradley, we good there?
Yeah.
Then you're really just kind of ignoring the roots. You're just doing -27 plus 20 minus 18, right?
Yeah, just be careful. I don't know. I haven't checked the other ones. But this one, the only reason why we can add and subtract is because we have the same root, right? It's kind of like terms. We talked about like terms in polynomials there. We can't add and subtract these unless they have the same root.
But they did have the same root.
Yeah, we just leave it. So if I had 3 root 2 minus 4 root 5, I keep that as is. That would be my answer. That'd be my answer. But going back to it, -27 plus 20 is what? -7,
Yeah.
okay? -7 minus 18 is -25, and then I keep the square root of 2. That would be my answer, okay? Does that help? Are we good on those? All right. All right, let's go. Do you want to keep going? I mean, is this working? Just keep rocking. All right, let's go to number 10 to 12, okay? Is there anyone on numbers 10 to 12 that you want me to do? Let's do 11. All right, rationalize. Talk to me about rationalizing. What's rationalizing?
Don't you do the opposite of the bottom, like square root 13 minus 3 over square root 13 minus 3?
Good. That's Nate in his house. Bringing it home.
That's the first time for everything.
Miracles happen. No, I'm just messing.
Cowboy,
No, I'm messing about that. Nate came in the clutch. That's good. So we're going to multiply by what we call the conjugate, right? It's just a fancy word of saying whatever's on the bottom, same thing, except the change in the middle sign, okay? So that's why we multiply by square root of 13 minus 3. All right, I will haunt you and your children's children if you change this to a plus. It's not a plus. Remember, change that middle sign, okay? Keep that as minus. So let's multiply the top first, okay? What's square root of 2 times negative, or square root of 2 times square root of 13? Great, good job, Hans. Square root of 26, right? We multiply the insides, and if there was an outside, we multiply that together as well, okay? So we'll keep it as square root of 26. What's square root of 2 times negative square root, or negative 3?
Negative square root of 6.
Well, be careful. This is the outside, right?
So -3 square root.
Negative 3 square roots of 2. Good. Okay?
Yeah, negative 3 is good.
Because that's the outside and that's the inside. Now let's keep going. We'll try to do more of these. What's square root of 13 times square root of 13?
169.
Quick question. Do you
Nice.
foil this?
Yes, that's exactly what we're doing. We're foiling. So, or distributing, depending on what you float your boat there. But yeah, we're just multiplying with square root of 13 by each, and let's write that down. So yeah, square root of 13 times square root of 13 is square root of what? 169, which is what? The same thing as 13.
Is that almost
Right?
always gonna be the same? Is not
Yeah,
always gonna be the case?
Exactly. So what is square root of 5 times square root of 5?
25, 5.
It's just going to be 5, right? What is square root of 9 times square root of 9?
9.
9. What is, Riley, what is the square root of 100 times the square root of 100?
100.
100. Good. Good. Does that make sense? Okay. So again, that's kind of what we're using there. What's square root of 13 times negative square root or negative 3? Good. Negative 3 square roots of 13. Perfect. Perfect. All right. Let's go to the next one. Let's go 3 now. What's 3 times square root of 13? Good. The blue
What
one.
is it? It's just you don't really add them. You just combine them together.
All we're doing is multiplying right now, right? We haven't combined quite yet.
You just 13 minus 3 squared plus 3 squared.
Now let's do the last one. What's 3 times negative 3? Negative 9. Now, do you
Cancel out.
perfect? These cancel. Remember, if you did this right, there shouldn't be a square root in the bottom. If you have a square root in the bottom, then go back. You messed up. Okay.
13 minus 9 is 4.
Yep. So 13 minus 9 is 4. So I get 20 squared root of 26 minus 3 root 2 all over 4. Okay. All right. The bell's about ready to ring. So if you're listening online, it's okay. Everything's good. We'll continue in here shortly. All right. So that is number 11. Number 11. Guys, see ya. Absolutely. Yeah. All right. Numbers 13 to 14. Is there any ones on there that maybe you struggle on or? They're all kind of the same. Yeah, it's just foiling, right? What does squared mean on 7x minus 6?
We do that one.
Yeah, what does that mean? That means there's 2 of them, right? So let's put 2 of them there. Yep, so what's 7x times 7x? What's 7x? Yeah.
That is 40.
Okay, what's 7x times 7x? Let's start there.
Oh wait, that's
Okay, you could say 7x squared. What would that be though?
it's
when I'm
49x squared.
Nice, good. What's 7x times negative 6? And you said it right earlier. Negative 42x, right? Okay, now let's come back over here. Let's start with this negative 6. What's negative 6 times 7x? Good, negative 42x. And then finally, what's negative 6 times negative 6? 36. Excellent. Okay. So what we have now is 49x squared. And what about this negative 42x minus 42x?
Yeah.
Negative 84x and plus 36. Okay. Can I combine anything there?
No.
I can't, right? So guess what? We'll leave that as is. That'll be your answer. Okay. Does that work?
So if you can't do anything past that, that's it.
That's it. That's all we got. That's all she wrote. Okay. Again, I'm just going to keep rocking. It seems like this is helping. Okay. So again, as we keep going through it, that's true. That's true. 16 to 18. Remember, you only have to do 2 of the 3 of those. That's important on the podcast too. You don't have to do the whole thing.
Oh, we only have to do 2 of each.
2 of each set. Yep.
Wow.
That's it.
I'll still be doing all
on
of
the
it.
entire review.
Yep. Entire review.
You only have to do 2 of
2 of the 3 per section, right?
So
I'll be doing all of it still.
That's fine. Yeah, that's cool. All right, 16 to 18. What do you think on those?
I don't know how to do this.
Yeah, I'm very confused on this.
Okay. Does it matter which one?
No.
Could I do number 17? I think that one would be a good one. Hans, are you hanging with us? Or you got a class here?
I have academics right now. So
Perfect. That's fine. Yeah. Awesome. All right. So on this one, on number 17, this is one where we're adding and subtracting. Now, if I add and subtract, we call this rational expressions. Okay. Rational functions sometimes. In this case, what do we need to do in order to solve these?
Get the same denominator.
Bingo. If you remember that, add and subtract by
Oh, yeah.
fractions.
Okay.
I got to get a common denominator. If you can remember that, you're going to be golden. Okay. If you don't remember that, good luck, because you're not going to do. You won't get it right. Okay.
I know how to do
So go ahead, Riley.
Yeah. Okay, so you times the x plus 5 side by x minus 5 top and bottom.
Good. I like how you said top and bottom. Good.
Question: Could you? It doesn't matter. But could you just do the opposite of that? You just do the x minus 5 times x plus 5. Or does it really matter? Does that really matter? You know what I'm saying?
Yeah.
Instead of using x minus 5, I just question: Could you use the x plus 5?
No, because this one, what is the common denominator we're trying to find?
X plus 5, X minus 5.
Good. That's what we're trying to find, right?
In that order.
It doesn't matter in that order. You just need that in the bottom. So in order to add these two, I have to get where both of them have the same thing. So if it already has an X plus 5 and I put an X plus 5 here, that wouldn't make sense because that wouldn't get us to what we're trying to get to. And that's the common denominator.
Yeah.
Does that make sense?
Yeah.
So we multiply by X minus 5. What about the right side? What do we multiply this by?
Usually.
X minus.
Well, it's got to have an X plus 5, right?
5, top to bottom.
Good. Okay. Now, Riley, can you go ahead for me?
2x minus 10 on top.
Good, because we distributed, right?
Yeah. And then x minus 5, x plus 5 on the bottom, and 4x plus 20 on the top of the other one.
4x what? Plus 20?
20.
Okay. Good. Okay. What are you going to do now?
Distribute the negative.
That's a great job. Yeah. So what she did was she multiplied by 5 throughout, but then this negative's got to affect everything on this right side. So that will change the sign of this 4x as well as this 20. So I could change this to a positive. That's fine. But now I have to change the sign of the 4x and the 20. Okay?
Negative 2x minus 3.
Yep, that's it. Negative 2x minus 30. All over what?
All over X plus 5.
X minus 5. Good. Are we done yet? Remember restrictions?
X cannot equal 5, X cannot equal negative 5.
Perfect. That really would be the complete answer. But at the same time, that's really good. Great job, Riley. Good job, Basil. That's it. Well, we're trying once we get a common denominator, right? Correct. We got a common denominator, then we can leave it as is. Good. Right on. All right, are we good then on that one? Do you want to do one from numbers 19 to 21?
Well,
What number would be helpful for y'all? 21? Okay, let's look at it. Let's look at 21. All right, 21 is, well, I'm going to ask y'all, what do we do on 21 to be able to solve this?
you have factor first.
Factor.
Yep, that's exactly right. So, yep, if we can factor, that'd be extremely helpful for us, okay? So what would the top left factor into? I'm going to put these in green instead of rewriting these. What would I factor the top left to?
X and X. And then negative 2 and negative. Or, no. 10 and 10.
Good,
Negative 10, negative 10.
good, good. And Hans, you said that too. Good. What about the bottom left?
7 on the outside, x.
Good. If there's one that you don't get, let me know, okay? So stop me if you don't understand one.
Don't you flip on the right side?
Good, because of this is dividing, right?
Number 19.
We could change this to multiplication, but we have to flip this on top. So really what we're doing is 42 over 6x minus 60, right? So really this part right over here on this side is flipped, and now we're changing this to multiplication. Good, that's important to note, okay? Can I factor anything on that right side now?
X minus 10. So to read 6 out and 6.
Good.
X minus 10.
Good,
And then you can just cancel your X minus 10s.
good. So this part up right here, this is what we have, right?
Yeah.
Make sure if you're gonna do that like I did, you can do it. But I would, if I were you, once you're done, cancel these out so you don't get confused, okay? See what I'm saying?
Yeah.
All right, so what can we cancel out? I know we were,
X minus
X minus 10? Good, both of X minus 10s, nice. Anything else?
All of them.
Cancel what out again?
All of the x minus 10s.
Correct, you're right, very
Oh,
good.
Flip,
And then you just multiply the 6 and the 7 together.
Good, yeah, we multiply the 7 and 6 together to get what?
42 over 42, which is 1.
Nice, good. A lot of people will cancel this out and say 0. If you do that, I will haunt you and your children's children. And for those of you who are seniors right now I'm talking to, I'll haunt you. I'll come to your college. I'll haunt you. I'll tell you that right now. Not in a non-creepy way. All right.
That would be really creepy. Just Coach Jay shows up at my college.
That's
dorm.
right. What if I should. I'm back. Awesome. All right, let's go to the next page. First off, any questions on the first page for y'all? Awesome. Okay, let's go to, I'm going to solve now 22 to 24. Are those ones we need to go through? Any one of those? Those are just the PEMDAS solving.
Oh, just like, okay, no, probably.
Are y'all all good on that?
Yeah.
Riley, are we good?
I'm down with that.
Okay, so we're good on those.
Yeah.
22 to 24. If y'all need one of those, come and see me, and we'll look at those together too. What about solving? 25 through 27.
What do you mean solving honors?
This one's using the quadratic formula. X
Yeah.
equals negative b.
Yeah, that was like when you just plug it in A, B, C.
Yeah.
This when you like for like 25, you subtract 3x minus 2 to get on the both sides to get on the right side, right? Or you
Yeah,
add
so-
both of those.
Yeah, we could do number 25. That's cool.
So 25 through 27 is the quadratic.
Yeah, but when they say solve like that, the reason why, look at numbers 28 through 30, or really 28 through 33, all of those are solved by factoring, right? Does that make sense?
So
So this is different. This is just solving, which is different on this one, okay? Now, sometimes if I take a factoring one, I can also use the quadratic formula. However, the reason why I'm using the quadratic on this one is because there's no way to factor it to get to the answer. Does that make sense? So that's why we're doing that. So to answer Basil's question, the 3x squared, I always want the x squared to be positive. That always helps me out. If not, it can get kind of confusing. So let's make that positive to make it 3x squared. Let's move the 12x over. Add 12x, right? And add 2. Okay? Did I confuse anybody by doing what I just did? By
You
adding
added
it?
both sides to get on the right side.
That's it. What I do to one side, I do to the other.
Question, if I
And
just
this is
mess
where I
up
get
and
this
make a mistake and I subtract 3x, is that fine to do that?
You could.
Does it make
If
it
you were
harder?
to factor, it's going to be harder.
Okay.
For the quadratic, it makes no
Have as
difference.
many positives as
There.
possible, right?
Yeah.
Okay.
It makes no difference on the quadratic because you just plug -3 in for A.
Okay.
But for factoring, it makes it a little tougher. So what do y'all have questions on? Is it how you plug it into the quadratic or what you get out? Or
Wait, how do you know this is not factorable? You just know it's not factorable.
well, it said to solve. I think I don't want to make sure I'm careful on this. I think I said on there solve by using the quadratic.
Okay, then it's fine. Right?
I think we're fine. If I just say solve, then a lot of times you're going to use quadratic. If I said solve by factoring, then you know it's going to be factorable there. Okay, so we have x equals negative b. B is 12, so we're going to plug in. Plus or minus the square root. What is b squared? What do I plug in for b squared?
144.
Good. Does everyone understand that? Okay. Then minus 4, what's a times c?
6.
Yeah, a times c is 3 times 2, which would be 6 there. Okay. And all over 2 times a, what's a again?
3.
3, right?
6.
So this would be 6. Okay,
And
good.
If we have a calculator, we can plug all that in right here.
Be careful. Be careful. Because this one right here, you're going to have to give it to me in a simplified answer.
Okay.
Okay, so now we got x equals negative 12 plus or minus. Let's look at the square root. What do I do in here? Do I do 144 minus 4 first?
So why is it negative 12? Oh, because it's
Negative b, right?
let's multiply 4, not negative 4, 4 times 6 to get 24, and then 144 minus 24 is
Nice. I hope you all heard that on the podcast because Mike brought us some good wisdom right there. Yeah, 144 minus 24 would give us what? 120. Good. So really, I've got negative 12 plus or minus the square root of 120 all over 6, right? So we've got this here. But that's not my answer because what can we do with the square root of 120? Oh, we're coming back, right? Yep. What two numbers make up 120? 10 and 12. Good. But I don't see any pairs there yet. Is there any? Well, can we break this down?
2 and 6, 2 and 3.
Good. We could do that. So really, all of these are the numbers that are what we call prime factors. Okay.
You're gonna bring out. Go prepare the two. So you're gonna bring out a 2.
Good, bring out a 2.
And then leave in a 3 and 5. And so 2 times 3 is 6, times 5 is 30.
Good. So all of these are multiplied because there's no pairs, right? So we're going to keep 30 on the inside. What comes to the outside?
2.
2. Good. So this is something I know even Riley, who said she knew this, this is something that a lot of us struggle with, is what we do next. Here's what I would recommend. 2 root 30 is here, okay? All right, 2 root 30 is here. I would take 6, put it underneath negative 12. I would take 6 and put it underneath 2 square root of 30. So here's how I would write it. I would say negative 12 over 6 plus and minus 2 root 30 all over 6. Okay? Because now what I can do is I can reduce here. What's negative 12 over 6? Good. So negative 2 plus or minus. And 2 and 6, what happens there?
The bottom becomes 3.
Good. Remember, you can't go inside the square root, right? Don't go inside the square root, meaning you can't say 3 goes into 30 10 times because it's inside my house, okay? You come in my house, start stealing stuff away, we're about ready, it's about ready to be real, okay? So don't go in the house, whatever you do there. So that would be my answer. Negative 2 plus or minus square root of 30 all over 3. Boom shakalaka. All right, Mike, what are you thinking? Where'd you struggle?
Getting, however you got 2 square root of 30.
How I got to 2 square roots of 30? Well, you know you get how I got these numbers down here? Just by breaking it down. If you struggle with that, I would highly recommend rewriting. So 2 times 5 times 2 times 2 times 3, right? Is there a pair? What do I do with that pair? Bring 1 to the outside. Good. What's left in the inside? Yep, we multiply everything else. Good. So that's why it's 2 root 30. Does that make sense now? Sweet. Okay. All right. What about say again? They are. Yeah. It was a senior thing today. I don't know if you heard about that. They brought donuts for everybody.
Really?
Yeah.
You got that idea during your class. It was during
Yeah.
your class that I got
I
the
didn't do
idea.
that.
Yeah. That was pretty cool.
Thank you.
That made my day. I just tweeted about it too. That was really cool. Really cool. All right, 28 through 30, what are you thinking? All right, 29 and 30. Do you all understand how to do, like, what 2 numbers multiply to equal the outside, add to be equal to the inside?
Wait, question. For this one, would you just subtract 3, put it on the, for 28, and put it on that side?
Yeah, I wanted to do that one. Could I do that one? Because A is greater than 1. So I wanted to ask you, this one right here, 7x squared, number 28. Minus 20x equals 3, right? Remember on this one, like, okay, so when you have A is greater than 1 and I say solve by factoring, Basil's right, we got to subtract 3 on both sides. So where now we get 7x squared minus 20x minus 3 equals 0, okay? In this instance, we are trying to find like 2 factors, right?
You
How-
have 1 and 3 to be can do.
Okay, so I was going to ask Basil, do you do like check and guess?
Yeah.
Okay, does everyone do check and guess? Mike, do you do check and guess method?
Sure.
We're going to take check and guess with Mike. How about that? Hans, are you good with check and guess? Number 28.
We have plus 3 and minus 1.
Okay.
We do 7 times 3.
Yeah, so really there's 2 different types, right? Okay. Well, first off, let's backtrack. Really, there could be 2, really could be 4 possibilities, but we'll try different ones. For instance, we know this is -3, so the outside values have to multiply to equal -3. So you could do like -3 and 1 or -1 and 3, right? So I'm just going to guess. Is that cool? So I'm just going to say -3 and 1. We good there? Okay. So now we have to ask ourselves, what 2 numbers, when multiplied, get me to 7x squared? So we know that it's going to be something x and something x, right? What two numbers multiply to get me to 7? Which would it be?
Or 1 and 7.
7 and 1, right? So really, there's only one possibility for what can be on the front. 7 and 1, okay? So you could either have 7x minus 3, x plus 1, or it could be 7x plus 1 and x minus 3. So you have to kind of test it out, okay? Really, the kicker is, what can we do to get to negative 20x, right? We know that when we multiply the first times the first, that's 7x squared. And negative 3 times 1 is negative 3, but what happens in the middle? So what's 7x times 1? Good. What's negative 3 times x? Good. Does that add up to equal or subtract to equal negative 20x? No, right? We're good there? All right, look at the next one. What's 7x times negative 3? Negative 21x. Good. Make sure the sign's there. And 1 times x is? Plus x. Okay? Now, again, do you see how I did that? There is no guessing to how I can get to these two. Really, the guess is how can I use those to get me, and like change it around to get me to negative 20x. So really, the only distributing that I need to do to check is 7x times negative 3 and 1 times that x to get to see what that will end up being there. So then what does this add up to be equal to? Negative 20, which is my answer, right? So what can I do with 7x plus 1 and x minus 3 to solve?
Set them equal to 0.
That's it. Set them equal to 0 and let's solve this thing. Okay? Riley, what would x be equal to with x minus 3?
Plus 3.
Good. And Riley, do you know what this would be with 7x plus 1? 1 Mississippi. No, I'm just messing.
Just shut up.
Wow, you just heard that on YouTube right now. Shut up to Coach Johnson.
What are you guys doing right now?
Negative 1 over 7.
Mm-hmm. 3 and negative 1 over 7. Okay. Does that help?
Yeah.
I'm guessing number 29 and 30 are easier, aren't they? Because those ones you just, yeah, and 29 is what two numbers multiply to get me negative 99, but when added get me to 2.
On 30, would you subtract x minus 2, or would you add, like, how would you get them all on the same side?
You mean subtract x, subtract 30?
No, like, don't you need to get them all on the same side first?
Mm-hmm. So,
Subtract x, subtract 30. Like,
Yeah.
Okay,
to be x squared minus x minus 30.
okay, you got it.
So it'd be what? X minus 6x plus 5? Something like that. What two numbers when multiply get me to negative 30, but when added get me to negative x? That's kind of what we're doing there. All right. Be sure that you look at number 28 again, okay? That's one on the test that you want to make sure you're ready for. All right, what about number 31 to 33? Talk to me about that one. Any questions on that one?
Which one? 31 to 33.
Mm-hmm.
Just pull out an x and then set it equal to 0.
Yeah, like could we do number 31 just to make sure?
Yeah.
So we have 3x squared minus 8x. Mike, talk to me about it. You were talking to me about that. What would I do to solve for that?
Pull out an x to start.
Okay. When I pull out an x, what do I have left over?
3x minus
Good. So what do I do to solve for these?
well, x is already equal to 0, so that's 1.
Because of that, right? Don't forget, a lot of people forget that one. So just be careful, those on YouTube.
So add 8
Mhm.
divide by 3.
Good. And so what would be the next 0?
8 over 3.
Yeah, 8, and then divide by 3 to get 8/3. Yep. That'd be it. Did I go too quick on that for anybody?
Nope.
Okay. Good stuff. I'm guessing now is where we may have to go through maybe a little bit slower through some of this stuff. So as we keep going, we are done with chapter P. Literally 1/3 of the review is done as far as those problems are concerned. So great job on that, y'all. Let's look at 34 to 36. Do y'all have, I'm guessing one of those, right? Preferences? Any preferences? B-Dub is in the house. What's up, dude? Get your donut back there. Don't thank me. There was seniors that brought those in. So, all right. So we don't care?
No, just do anyone and I'll be happy.
35. Let's do it.
Okay.
Now we're just trying to find domain, okay? Just domain. You'll still have to find range, but range will be, you'll have to solve for range when you do ones like 37 through 39. That already give you the graph, okay? The ones that I'm doing here are ones where you just have to find the domain on this one, all right? Now I'll tell you, the only thing that not having a note card does, first of all, I went through the test, took the test. You really don't need a note card, okay? I think it would almost hurt you having a note card. And I mean that. I really do, because I gave you all formulas that's there. The only thing that I would say that might hurt you is problems like what's behind me. Because right now you're probably thinking, or before we do it, you're probably thinking, well, how do I even approach this? A note card may be able to help that. But there's very few of them like this. So in both of these problems, we're trying to see where's the domain restricted, right? What restricts the domain? For instance, and by the way, we're going to do this in interval notation. That's important.
Number 34.
This is number 35. So let's start with this one. Do you know of anything that the domain cannot be equal to? First of all, domain's related to what? The x. Very good, B-Dub. Okay. It's also left and right. Okay. X, left and right. What can x not be equal to in this? Good. Why? Why is that?
Why is there A and B?
There's just two different ones we're finding the domain of. They're two separate problems. This would be like the A part, B part. I'm doing the B one first just so we got it. Yeah, so really x could be anything, but it cannot be equal to 3. Okay? Does that make sense? So literally, it could be all reals except x cannot be equal to 3. Now here's the problem. We've got to put that in interval notation. Okay? Now normally, if it can be all reals just means that it can go from negative infinity to infinity, right? That's all that means. Okay? But what can x not be equal to?
3.
3, good. So can someone put an interval notation to where we kind of put a break into action at 3 right in the middle?
3 bracket.
Well, remember bracket means equal, right? So if it's not equal to it,
It includes 3.
correct, so it can't. So we're going to keep it as parentheses, okay?
I thought when you had numbers, you put a bracket around them.
A lot of times we do. We're going to actually look at one like 37 to 39 there in a second. A lot of times it does. However, and I don't want to get too into logistics or anything like that, but this graph will look something like this. It would have a vertical asymptote right here. And like this graph would approach this x-axis, but it won't touch it. Does that make sense? So it means it could come to 3, but it can't be equal to 3. Okay? So this would be negative infinity to 3 as well as what? Because we got to include this one, right? 3 to infinity. And what do we put in between?
U.
The u. Good. Good job, Hans. Just use the u. That's it.
So we are allowed to bring up no card?
You're not. You're not. That's why I said on the actual final, for every problem I put what formula you will use. I said the only thing that would hurt you on stuff like this, but that stuff we should know anyway. Hey, when x is on the bottom, x cannot be equal to whatever makes that 0, right? All right, so that would be what we would have here. What about for square root of 3x minus 1? Good, yeah, we equal this to 0. Why do we do that?
I don't know.
Can this be negative on the inside? Why can't I have like square root of negative 1? Well, it's possible to solve, but it's not real, right? It's remember imaginary numbers?
Yeah.
Remember that equals I? We can't have that. You can't graph imaginary numbers, right? So we're just talking real numbers. So if I set 3x minus 1, whatever's inside the square root, this has to be greater than or equal to what? 0. Because if it was less than 0, then it would be It'd be negative, right? And it would be imaginary. Is there anyone that struggles on that right now? Okay, Mike, let me talk first. Do you understand this right one? No? Okay. So 3 minus x, right? If this was 0, it would be undefined, right? I said equal to 0 and know that x can be anything except it can't be equal to 3. Correct? So meaning that the only thing that stops this graph is that number at 3 or that value at 3. So literally, this graph is going to be from negative infinity all the way to 3 because it can't be equal to that. So it stops, right? And it could be from 3 to infinity. The reason why I can put that there is because it doesn't have a bracket, right? It won't be equal to it, but it can approach it. So we say negative infinity to 3 and 3 to infinity.
So that was, your answer would be just be 3x minus 1 less than or equal to 0.
Then it has to be greater than or equal to 0. Well, now, Mike, can you have a negative number inside a square root? So what is the lowest number that I can get out of a square root? That's a tough question. I mean, you know it, but it's just tough to think through. What's the lowest number that you can get out of a square root? Very good. Can I take the square root of 0? Mm-hmm. You still get a number, right? What's the square root of negative 0.000009? Can you do it? Square root of, can I do the square root of negative Hans?
No.
No. Can I do the square root of negative Coach J? No, I can't. Okay? I can't do a negative of anything inside of a square root and get a real number out. So the lowest number I can get is 0. So whatever's inside the root, I set it greater than or equal to 0, meaning x can be anything that produces 0 or anything greater, but anything that produces less than that, I can't have. No, I just, all I did was take the 3x minus 1 out, okay? So now how do I solve for x? Okay, good. So now we've got 3x is greater than or equal to 1.
So x is greater than or equal to 1/3.
Can you put that in interval notation for me? Something that looks like this.
How did you get 1/3 over there?
Because I added 1 and then I divided by 3. You see what I'm saying? You see, you understood how it got to here, right, Basil?
Oh, yeah.
I just added 1 divided by 3.
Then you'd have negative infinity, comma 1/3, and then 1/3, comma infinity.
Question though, can I produce anything that is less than x, that less than 1/3?
No.
No, because x is greater than or equal to, right? Bingo.
1/3 to infinity.
Good. So 1/3 is the lowest value that I can have. Why? Because if I plug 1/3 in for x, what would I get out?
0.
0. And what is 0? The lowest value I can get out of the square root. Does that make sense? Now, can I have anything greater than 1/3? Yeah, because I don't care. It could be, I mean, to infinity and beyond. So once I do this, I have infinity. What happens? What do I put a bracket or a parenthesis here? Parenthesis, always with infinity. What about 1/3? Bracket. Good. That is what we get out. Okay? It's a little tough. I think if I was to be honest, I think you get this one. This right one. I think this one's a little bit of a struggle.
Yeah.
Okay? So what I'm going to do is this. I want you to do this. I just did number 35, A and B. Okay? I want you right now to look at 36A. That's it. Just 36A. I'm going to give you like 2 seconds to be able to do this, all right? For those at home, once you get the answer, I want you to yell it in your house. Okay? Literally yell out the answer in your house. All right? Perfect. I'm going to give you just a second. Me done the other. Correct. Nice. And I did more of those on the podcast too.
Okay. I think that's like the thing I did most.
You get that most? Good. Man, y'all, we are rocking through this stuff. I hope this is helping you.
Wait, there's a movie tonight?
Yeah, movies tonight. I'm going to send out a reminder. 7:45. In fact, I'm going to do that now.
I'm looking for it.
What time is session?
10. Yeah, I'm going to probably stop about 10:15. I think you're going to find that we're going to get through a lot of stuff up until 10:15. I mean, right now, yeah, I would think 10:15 would be sufficient.
Maybe like restart tonight.
When I start tonight's podcast or tonight's study session will not be podcasted. It'll be at the rustic couch. So literally, I'm going to have pre-cal in Algebra 3. So we're just going to do 2 groups, and we're just going to work together through any questions we have. So it'd be kind of like more like a free-for-all. That makes sense? Now, tomorrow from 1:30 to 3, I'm going to podcast that one too. And what I'm going to do is I'm going to pick up, I've highlighted the ones we've done. We'll pick up where we left off on this. So I'm podcasting different things. Does that make sense?
I get this one. I get this one. I brought that one out of time.
Good.
And then I just time
12 root 6. That's perfect. That's perfect. All right. I'm going to get this one in just a second. Did y'all figure that one out yet? Sweet. I've got one. Let me do this. 1, 2, 3. 2, 3.
For the quizzes, are we allowed to do that the rest of the time?
Yeah. Would you mind texting me? Or is that what you want to do there? Okay.
I'm gonna text you. I'm gonna text you later on in the day. That's like my bad, so I'm not sure.
Yeah. Could you just text me? That way I know if I need to bring them or not. Be cool. Let's send out a reminder real quick. Remind 101.
You see that we only have to do one problem per section to take it?
2. Or no. To take the quiz, you have to do all of them
So
per
if
section.
I did that on the quiz, just say the chapter.
Yeah, it doesn't count for you unless it helps you.
So basically anything on
Mahima, what's up? How we doing?
How much?
Join us. Yeah, we're doing good.
Welcome to my humble
I
abode.
hear you.
Hey, money,
I brought my whole house.
Could I retake the quiz for chapter 3?
Check some of that bill.
Oh, hold up. It's not a retake. It would just go in for a separate category. However, it still helps you. Yeah, still helps you. Yes. Tomorrow morning. No. Well, the problem is that I've got pre-cal from 8 to 10:45. So if you can fit in a time like before 8 o'clock, that's fine. Yeah. Come on.
Whatever you say. Which one did you say?
Right now we're doing number 36A. I'm just getting this out.
When could I retake or when could I make take up the quiz? Not make it up, just take it.
You just figure out a time with me. I'm pretty open.
So is rustic couch from 5 to 7 or 3:30 to 7?
5 to 7. It's different. I think I sent out a message on that. There's some things that came up with baseball I'm helping with, just something. So I'm going to go from 5 to 7, and we'll share that time with algebra or pre-cal. I'm doing something different when we're there. So it's not like a study session like I'm podcasting right now.
Right.
So, yeah. And we just took a quick break, so we're coming back here shortly. So.
You should plug your computer in.
Oh, man. Yeah. Does anyone have a charger by chance?
I do not.
Do you mind? Thank you.
Everything. I like how you're just like bundled up. I'm sick. Hello, everybody. You're sick.
I'll go back and stay right there.
It's allergies.
You're the man. Thank you, sir.
I just like it's my throat and my head.
All right, let's do this. Just because I know this is podcasted and I want to make sure I utilize the time of those that are watching here, I'm going to, we're picking up right now, just for those of you who have just joined us, Dynasty and Mahima, just so you're aware, numbers 1 through 36, we've already covered. So if you have any questions on those, I go back through. Tonight at the Rustic Couch, I'm opening it up for any questions. So at that point, if you want to ask any questions then, feel free to do that if you're coming to that tonight. But for right now, just so that I continue to podcast different things, we're just going over one after another, okay? All right, so right now we are on 36A. We already did 35, but we just wanted to look at one more of these. And so we're going to look at f of x is equal to square root of 2 minus 3x there, okay? Now remember when we solve for this, we are doing what with 2 minus 3x here? Those of you who did this, what do we do with 2 minus 3x here? Okay, we could set 2 minus 3x greater than or equal to 0, right? Perfect, yeah. Now this one, you're gonna see this in just a second what happens, but we'll get to it. What do I do now for x?
Okay, you can do 2 minus 3x.
Greater than or equal to 0, right? Good, we're gonna subtract 2 on either side, right? And remember, just so that we kind of review for those on the podcast as well as those who just came in, the reason why we make it greater than or equal to 0 is because we can't have anything that is negative inside of the square root. So the lowest value I can get out is, and anything that's greater than 0 I can get out as well. So now I get negative 3x is greater than or equal to negative 2, okay?
No, it's just negative 2. It's just 2 over 3.
Good. So once I divide by negative 3, I get x is greater than or equal to what?
2 over 3.
Okay, now question. Here's the only thing. This is the reason why I picked this one. There's one thing wrong with this. Can anyone identify what is the one thing that I needed to change?
Let's flip the sign.
Yeah, why do I flip the sign?
I don't know.
Divide by a negative.
Because I divided by a negative.
Okay.
Does that make sense? I don't think there's one of those on the final. However, because I remember taking it. However, just kind of keep that in the back of your mind, okay? So if you divide by a negative number, we'll have to switch this. So now it's x is less than or equal to 2/3, okay?
Now you do negative infinity, comma 2/3.
Good. Because it's less than or equal to 2/3, we'll do negative infinity because it can be less than, but then it goes up to 2/3. So what about negative infinity, bracket or parenthesis? Nice. And 2/3 would be? Bracket. Nice. And we'll leave that as is, okay? All right. What about b real quick on that section? 4 over x. What can x not be equal to?
1, 0,
If I had 4 over 4, could I have that? Yeah, I can. What's the only thing? What's 4 over negative 4?
0.
0 is the only number, right? So x cannot be equal to 0. What's that in interval notation?
Positive.
Close, yeah.
Positive.
Okay, that's part of it. And negative infinity to 0, right? And then put that union there too. The gangsta symbol.
Oh God.
Gangsta.
Wait a minute. Why? I thought you couldn't have negative numbers. Like,
Hold up, you mix that up, right? Right, we're talking right now on the B section where we have 4 over x.
oh yeah, okay.
That's the only one, okay? Speaking of gangsta symbols, that reminds me of one back in the day and when I grew up in the hood.
Yeah, yeah.
It's true. I actually did grow up in the hood, kind of,
You
sort
want
of.
to demonstrate your symbol?
The symbol?
No.
Where are you from, Georgia?
No, well, I mean, I grew up a lot in Georgia, but I actually was born in San Francisco. And yeah, true. This is completely true. When I grew up, when I think it was like 2, we lived in an apartment complex where there was some gunshots outside of like it was not a good place.
It's fine.
Here?
San Francisco, yeah, that's true.
Was it by where they shot Full House?
I know where they shot Full House. I didn't live next to there. No, that's really expensive area.
One time my mom burned down the entire
That's
apartment
cool, right?
complex. Yeah, I'm not kidding. She was cooking and then she just
Only your mom would
burned down the entire
Wow.
house.
I'm
And
honestly not surprised.
If you're hearing this right now, I am sorry. Sorry about that.
Literally
literally, I am not surprised. That would be something your mother would do.
All right, let's check out the next one. Let's go to, can we do number 38? I am guessing within 38 here that this is one we probably need to talk about. We have a couple of things. We have interval of increase, interval of decrease, constant, domain and range, okay? All right, let's get the stuff that that's the easiest, okay? Because I'm guessing tonight at the Rustic Couch, we'll probably do another one of these. Because this one is a tough one too, okay? 38, what is the domain of this?
Right.
Yep, domain is left to right,
And range.
low to high, kill them, dib-dab, dib-dab. All right,
I always hear my
Negative infinity, positive infinity.
good. So domain is negative infinity to positive infinity. Hint, look at those arrows. Now, the key on this one, and you'll see this one, this will happen on the final, okay? I promise you this. There will not be arrows. Look at number 38. There's no arrows, but the fact that it goes off the graph assumes that it keeps going. You see that on 38? So I put arrows in there. You can do that too, but just know that that's the case there, okay? All right, so what is the range?
0 to infinity.
Okay, so what's the lowest this graph goes on the y? 0, right? So I have one at 0. Good. And what's the highest it goes? 4. Good. Brackets or parentheses? Brackets because it actually hits and equals that, okay?
Also, range goes up.
Range goes low to high. Range goes low to high. Are we good there? Domain and range? Okay, perfect. How many of you struggle with like intervals of increase, decrease, constant?
Constant is
I get that. I like
Get
that.
that.
That's cool.
negative infinity to negative 1.
Good, yeah. So as I start from the left and like this roller coaster goes to the right, it is constant from negative infinity. Remember, we're looking at just the x, right? So it's constant from negative infinity to negative 1. Good. Is it constant or go ahead, keep going.
And then from 4 to 5.
Good. So is this 4 right here?
Is
that 3?
Thing in the middle.
Yeah. The U gangsta symbol, okay. From 3 to what?
No, it's 4 on mine.
Is it 4 on yours?
We're all blind. No, it's 3 through 4.
Oh, constant is x is my bad.
Yeah. So 3 to
3 to a positive.
positive infinity, right? Remember on this, we're looking at the x-axis. The one confusing thing people have is when you look at things that rise and fall or increase, decrease, or constant, you're looking at the y, right? The y change. But when you give it to me, label it on the x. You're looking at the x. So does anyone know where I decrease on this?
Yes, you do. You do it at that one dot to blue dot.
Yeah, what would you say of that? Say again, Riley?
-1 to 0.
Nice, good. B, tell me where I'm increasing. Bingo. Good. Some people like doing one at a time. Some people also like to do this. They'll say, oh yeah, from negative infinity to -1, I'm constant. From -1 to 0, I'm decreasing. From 0 to 3, I'm increasing. And from 3 to infinity, I'm constant. So it like goes from one to the next to the next. Whatever floats your boat, that's what you can do there.
So
Okay.
the down arrow is increasing? Or
Say that one more time. I'm sorry, Mina.
because you know how like for the down arrow you put like 0, 3?
0, 3. So what that means is this is not like a point,
Yeah,
right? It's
so,
not
like,
X and Y. It means that it's an interval. So I start at 0, and as I travel towards 3, in this section, I am increasing.
Why do you put on the
But like
down
why
zero?
is it on the down arrow? Because if it's increasing, wouldn't it be up?
Do you mean to switch those?
Oh yeah, I'm sorry.
Okay. I was like, what?
That's what I meant. There you go. This one's going down for real. No. I apologize if you're watching this podcast. All right. Are we good there? Y'all good?
Yes.
Okay. So I'm guessing through 39 we're fine. Again, if we need another one, we could do Rustic Couch. Is that cool? Or we could do one again tomorrow too.
I'll be here tomorrow.
40 to 42. Y'all have one.
40 to 42.
You want me to do one of those?
We can do all of them. if you want. For the good of the podcast.
Well, let's do one and let's see where we're at, okay?
By number one?
Yeah, or 40 to 42. What do y'all think? 40, 42?
Yeah, that's cool.
What one do you see that's really tough?
This is so funny. Oh, I know.
This one's basic, right?
I'm 40, right?
42.
Let's go 42. 5x plus 2y equals 10. Let's do it.
Okay.
In order to get this in a form we can graph, we need to get in what form?
Y equals mx plus b.
Yeah, slope intercept, right? So how do I get that into the same thing?
Okay.
Okay, you could subtract. What's up, Ryan? I tweeted about y'all today. I'm so proud of y'all. That was awesome. That was right on. I had donuts back there too. By the way, yeah, if you want donuts, turn them back. You could come here too. It doesn't bother me. So as we continue right now, okay, so just to give you a heads up, I'm podcasting all of these. Okay. I'm only taking one problem per section.
Okay.
Does that make sense? So right now we are on 42. I've already done all the ones previous. If I need to come back to those, I can do that either at the rustic couch or we can do it tomorrow.
What time is that again?
5 to 7.
Cool.
So does that make sense?
Mhm.
So again, just for the sake of the podcast, we'll continue. So this one, we're trying to get y equals mx plus b. What can I do to get this into y equals mx plus b form? That's what I would do. Yeah, let's subtract 5x here. This one's number 42.
42.
Okay? So we get 2y equals negative 5x plus 10.
Why are you checking by that?
Because we're trying to get it into y equals mx plus b form. We call it slope intercept, right? So we're trying to isolate y.
Why?
10 instead of 10 minus 5x.
Because it's y equals mx plus b, so the x comes first before the 10.
Why?
It just helps us out. It doesn't necessarily matter.
Why?
Yeah.
Why don't we,
I'm sick. I can't control.
Yeah, with what again? With the 2?
No,
Well, because we're not breaking up 5 and x, right? All we're doing is subtracting it to the other side, right? Now look at this, B, 2y. If I want to get y by itself, what do I do? That's why I'm going to divide. Good. So I'm going to divide by 2 on all of these, okay? So what would this equal then? Yep, y equals negative 5 halves x plus 5. Beautiful.
That's the answer.
That's our equation that helps us graph, right?
Yeah.
What does 5 tell me?
No, that's where our starting point.
This is our y-intercept, right? Okay. Now, again,
You go down 5 over 2.
correct. Now, I will tell you this. This comes back to the note card thing. There is no note card you can use on the test. Okay? You can't use a note card on the test. However, I'm going to give you the formula y equals mx plus b. I'm going to tell you that that's the formula you're using for this problem. However, what you need to know is what is b, what is m, like what is 5, and what is negative 5 halves. How do I use that? You'll need to know that, okay? So what do I do with negative 5 halves?
Down 5 over 2.
Yeah, down 2, 3, 4, 5 over 2. And if you do it twice, that's sufficient. So once you kind of do that twice, you'll get your line that goes through, and there you go. Okay.
How do you grab that again? You go up 5 and then
Y-intercept's here.
negative 5.
Rise over run here, slope. Okay. All right.
I'm still going. I'm just going to be late. The banquet?
All right. Let's go to this. Let's do this next one.
So from there you go from that point on that x-axis you go down 5 over 2 again.
Perfect. You could keep going to infinity and beyond with that.
Wait, it doesn't go to the left. Why not?
Say again.
Why doesn't it go left?
You could, in this one, instead of going down 5 over 2, you could go up 5 left 2. Does that make sense?
I'm saying now it's negative 5 over 2.
Yeah.
Does it negative just apply to the 5? So it's like you go to
Yeah,
the
because if I have 2 negatives, if I go down 5 and left 2, that's 2 negatives. What does 2 negatives make? Positive. Yeah.
If you wanted to put that in point slope form,
Yeah.
I could do that.
Well, I would probably in this case give you something where if I said, I'm trying to see if there is one.
If it was not on the test, don't worry about it. I just thought-
No, there will be one very similar. Could we do number 51? I know I'm getting ahead of myself. I'll come back to it. Sound good? I'll come back to those other ones. Sound good there?
Yeah.
So remind me, 46 to 48 and 43 to 45, I'll do one of those, okay? In fact, Basil, just to keep them in order, could I do 43 to 45, 46, 48, and then come down to the next one? All right, perfect. Let's do, 43 through 45, which one do y'all prefer?
I don't know how to do that.
Davis, what's up, man? Good to see you. What one?
I don't know how to do either.
40 what? 43.
We'll do 43, okay?
What is that?
Davis, we're doing an Algebra 3 podcast right now, so if you got something to work on, that's fine. That's cool. All right, so 43.
Oh, you just put in -1, right?
So we get x to the third plus 7 over x squared plus 5. Now, if I have f of -1, Basil, what that means, and because I know you said this earlier, -1 is my input. So what does that mean? That means anywhere I see x, I'm inputting -1 in to see what I get as my output. All right? 43, yep. So I'll have -1. Make sure you put parentheses in there. So -1 cubed plus 7 all over -1. Make sure it's in parentheses. Squared plus 5. Now, here's where just be careful. When you put this in your calculator, you can, because you'll have your calculator for the whole exam. But please, please, please don't just put -1 squared. Make sure it's in parentheses, okay? Otherwise, you're going to get a wrong answer out. In fact, if I were you, I would actually do it long way so you don't mess up in that way. What's -1 cubed? -1? Yep, plus 7. What's -1 squared?
Or, no.
Do you see that? You'll get -1 if you don't
Yeah,
do
I
that.
saw it wrong. I looked at it.
Good.
So you have 8 over 5, or over 6.
Hold up. This is
No, that's 6.
6 over
6.
6 over 6. Good. Okay.
He's tired. It's okay.
What'd you say there?
David's bothering me.
What'd you say, Basil?
Okay.
No. I'm what? No. Because I think, what did he say? I'm right.
Wrong?
Yeah, he was wrong. I was right.
Oh,
I was making sure, guy. I was making sure. And we're podcasting. This is great. I think we could go back. All right, so we got that one. Let's go on. I'm guessing we're good on 44, 45?
No.
No?
Yes.
Okay,
Yeah,
good.
that shouldn't be a problem.
Let's go to 46. Let's do 46. Okay.
Got it.
All right, so slope intercept form. Again, I'll give you this equation, y equals mx plus b. Okay, we'll put that there. Slope intercept. And we're going to come to, in a second, point slope form, which is, this is y minus y1 equals m times x minus x1. Okay, this is not this problem, but we'll come to that one next that Basil had brought up earlier. But this is slope intercept form. So in this example, 46 tells us the slope is 2/3. Where do I put 2/3 in? So it says slope is 2/3 for 46. M, right? So what we will do is just plug in. So y equals 2/3 x plus b. Okay? Now, question. How can I find what b is? Well, we got our equation, right?
X.
What do I need to do? Because I need to solve for b to find this equation, right? What do I do?
Y1 minus Y.
This is not this one. We actually could, but it's a little easier if we do it this way. What could we do with this to solve for b?
I'm confused what we're trying to put it into. We're trying to put it in y equals mx plus b.
Yeah, what two things do I need to, what two things stay put? We don't solve for them. Y and x, right? Okay, so we have to solve for m and b. We've got m, that's easy, okay? How do I solve for b?
Wouldn't it be
What do you just do?
4?
What other thing have we not used in that problem, 46?
Point.
question. Only that's
Six
passing through.
Yes, Basil.
We used to y minus 6 equals 2/3, and then at parentheses x plus 4.
You could definitely do that. Yeah, that's definitely a way.
That was backwards. Though.
Yeah, I'm doing it this way. However, Basil, what you said is perfect. You could do that way. So what can we plug in for x? Basil kind of already said that.
1.
Look at the problem. What does the problem say? What does it pass through?
X plus 4. X plus 6.
X.
Passes through 6.
Oh, yeah.
It goes through 6, 4. So 6 we plug in for x, and what do we plug in for y?
4.
4, right? Okay.
I'm tired.
Lord have mercy. All right. So 2/3 times 6. So can I reduce any of this? 3 goes into 6 how many times? 2. So what's 2 and 2?
4.
4. Good. So 4 equals 4 plus b. What does b equal? Lord have mercy.
I just said 2 is 1.
Did you just say 2 times? Oh my.
We divided it like 1.
This is what happens when we're out
All
of
right.
school for too long.
Hey, let's do this. Let's make sure. I'm good with the craziness, but again, remember we're podcasting, so help me out just a little bit.
Could you easily just do like 2/3 times 6 over 1?
Yeah. I mean, so let me backtrack. So real quick, we got 2/3. That's our m. Okay, that stays put. The x and y, we know since it passes through 6, 4, we could plug 6 because that's my x, right? And 4 is my y. I could plug 6 in for x and 4 in for y. When I do 6 times 2/3, 3 goes into 6 twice. 2 times 2 is 4. Okay. So then we get 4 equals 4 plus b. So how do I solve for b? That's why I subtract 4. So if b equals 0, and we already know what our slope is, my equation would be y equals, remember it's 2/3, x plus 0. Well, I don't even have to put plus 0. We just leave it as y equals 2/3 x.
Okay, so I thought we were trying to put it in that thing.
This one, right here,
Yeah.
this is point slope form.
That was not what we were trying to put it in.
Correct. It wanted slope intercept. I'll give you both, but that was slope intercept there. Now, the one we're going to go to now, Basil 51. They asked for point slope form, so we'll do that.
Whoa. Okay, so
Yeah.
wait. The one we just did. Got it.
Because 0 is b, right? Okay. Do we need another one
Wait. It'd be just be-
so we can get off the struggle bus?
So it'd just be y equals 2/3 x.
Y equals 2/3 x. That's false. Y'all been doing
That's
well.
all it would be? That doesn't make any sense. Why do we do all that work if it just came out to be that?
Can we do another one? Let me show you why.
Yeah,
Let's do it.
I'm confused.
All right, this next one, y equals mx plus b, because it says do the same, slope intercept.
What number is this?
47. Slope is 2. And it goes through -3, 2. Okay. So tell me what we could do here. I'm not going to teach this one. Good. 2 goes in for m, so y equals 2x plus b. Slope. Yeah, -3 is the x, and 2 is the y, right? So we can plug that in. So we'll have 2 times -3. Leave the plus b, and so 2 we plug in for y. Yep, so we get 2 equals -6 plus b. So Ryan, what would b be equal to? Good, because I add 6 to either side. B is 8. So if b is equal to 8, what would be the equation?
Y equals 2x.
That's it. Boom shakalaka.
What? Oh, yeah.
We just plugged in,
Got it.
plugged in m, plugged in b. Okay.
Yes, got it.
Let's go through number 51. That one is one that we want to look for. So if I say something is parallel, let's use this as an example.
The exact same opposite. No.
If I say this is parallel, right, to this line, another line's parallel to that, what would be the slope of that?
1/2.
Parallel.
Hmm.
Parallel means they will never intersect, right? So it stays the same. Slope is the same, okay? What if I said perpendicular?
Is it the opposite?
Nice, good, Mahima. So what would that be?
So 51 is
-1/2, okay? -1/2 for this one right here. Now for 51, let's look at this one. it tells us a couple things. First of all, it tells us it goes through 4, 2. And then it says that it's perpendicular. That right here, that symbol just means perpendicular to y equals 4x plus 7. And then it also tells us to put it into points. Y minus y1 equals m times x minus x1. Okay? So if it is perpendicular to this line right here, what would be the new slope for that I put in here? Kind of. Yeah, there you go. Nicely done, Davis. Davis comes in the clutch there. Nicely done. All right. Okay, so parallel means the slope would be what for this one? Parallel.
Bless you.
The same. Yeah, same. So it'd be 4, right? What if I said perpendicular to that 4? X. Opposite reciprocal, right? So it's not just 1/4. You have to change the sign to make it negative 1/4.
Negative.
So
Yeah.
y equals negative 1/4 plus 7.
Okay, be careful now, because this time they want us in point slope form, which is, again, I'll give that to you. I'll give that to you. So that means that in order to plug it in, you'll like this one. Because to keep it, you just put negative 1/4 in for m. And then it says x minus, x stays the same, right? So does y.
So x minus, whatever, x minus 2.
Wait,
No,
wait.
4. X
When you plug in the point,
Yeah, so what's the point?
4 2.
Good, so what goes in for x1?
Y minus 2.
Yeah, so 2 goes in for y.
Y.
4 goes in for x. So it's like Basil said, y minus 2 equals negative 1/4 times x minus 4.
Because you don't have a y.
Okay. Now, I'm guessing just because you did it on the previous one, look at number 50. They want us to do it in, oh, I'm sorry, number 49. They want us to do it in slope-intercept form, right?
Wait, so that
That was just what we did on numbers 46 and 47.
So that would be the
I mean, we could do it. That's fine.
so number 51.
Yeah.
That would just be the answer.
We just did 51. Mhm.
Yeah, I'm saying that would just be the answer. Like, you don't have to do anything else.
Nothing else. Not in that one. Now,
What number are we doing
this one is number 49.
now?
This one is perpendicular to y equals 1/3 x plus 8. So if we're trying to get this into slope-intercept form,
Negative 3.
good. The opposite reciprocal of 1/3 would be negative 3. So it'd be y equals negative 3x plus b. Okay. So in the example, number 49, Ryan, it says it's perpendicular to y equals 1/3 x plus 8, right? The new line in slope-intercept. So if it's perpendicular, what do we do with the slope?
The reciprocal.
And then the opposite sign,
So
right?
negative 3.
Perfect. And so all I did was plug negative 3 back into y equals mx plus b there. What's the last thing I need to solve for? B, right? We need b. So, yep. Point is 4, 4. We put 4 in for x. 4 in for y. Ryan, do you see what we did there? Okay. So 4 equals negative 12 plus b. So what does b equal to?
16.
16. So we plug 16 back in for b.
Y equals negative 3x plus 16.
Good. That's it. Holla at me. All right. I'm guessing we are rolling through this. 51, that was pretty good. I will tell you this next one's can be a little bit tricky. Okay? Can be a little tricky.
What do you want? What are you going to?
Let's go to 53. Is that cool? All right, let's go to 53. This one is finding the x and y intercept. Okay? The reason why it's tricky is not because it's necessarily hard. It's just sometimes difficult to remember what's my first step. Okay? Now, does anyone remember in x-intercept, what do we plug 0 in for?
Y.
Nicely done. Good, Mahima.
Look at you, Mahima.
For y-intercept, we plug 0 in for x. Got me? Okay. All right. So when I solve for the x-intercept, we plug 0 in for y, and the y-intercept, we plug 0 in for x. So watch this. To find the x-intercept, we're going to make 0 in for y. So 0 equals x squared minus 7x plus 12. I'm coming back to that. So if you're confused, we'll come back to that in a second. For y-intercept, we plug 0 in for x. So we should have y equals 0 squared minus 7 times 0 plus 12.
Wait, we don't have to like solve these stuff like
Well, we're going to solve it here in a second, but if you can know how to start it, you're going to be golden, okay? Are there questions on how you would start either one of these two? By plugging it in? Are we good there?
Yeah, but we put it into y.
Yeah, good question. So this one, 0 equals this, right? Bingo, let's factor this, okay?
I love factoring.
So what two numbers would make up 12, but when added give you negative 3?
4 and 3.
Both negative.
Good. Negative 3, x minus 4. So what two x-intercepts can we have?
4 and 4 and 3.
4 and 3, right?
Can't have them.
No, I can. That's different. Because I said it equal to 0, right? So it'd be 3.
3 and 4.
So how would I write that in terms of like x-intercepts?
3, 0. Oh,
No, you did that right. You're right.
0, 4.
3, 0, 4, 0, right? Because the x changes, the y does not. Y is 0, right?
You just have 12.
Yeah.
Why is it 12?
Yeah, so yeah, on this one, we'd say 0 minus 0 plus 12. So what's my y-intercept?
12.
12. So how would I write that?
0,
Right.
12.
0, 12, right? Because that is my y-intercept, okay? 0, 12. Do I need to do another one, or are we good on those?
One more.
Okay. All right. Let's see if we can do this in our head, or let's see if we can do this.
Let's
Quick.
not.
Okay. What's y-intercept?
Where are
This
we?
one's number 52.
Where are we?
What's the y-intercept for 52?
Wait. For the other one we just did, you just write 3, 0, 4, 0, and 0, 12.
Correct.
Minus 10. Okay, so
Are you
y.
gonna know what I meant if I just
Oh, yeah.
write? Okay.
That's I knew that. Yeah. Those are x-intercepts and y-intercepts.
Yeah, so you have y is 0 equals
Okay,
0
now,
squared.
You're
What?
on
We're on 52.
No, we just did 52.
No, we didn't.
53.
Okay,
See, leave me alone.
All right, here we go.
I'm ready.
We have 3.
Let's keep
times
this rolling.
0
Let's keep this rolling. 52.
minus 10.
Podcast.
If I put 0 in for, if we're finding y-intercept, we plug 0 in for x, right?
Yeah.
So what would be the y-intercept?
Negative 10. Just kidding.
Just positive 10, right? Because again, we don't change the sign. So that should be 0, 10 for my
Wait.
y-intercept, right? Because 0 minus 0 plus 10 would be 10, right?
Are we on 50?
52. Mhm. Oh, it is minus 10. So it should be 0, negative 10.
I was like, I'm gonna fail. No, this is not right.
No, you're right. X-intercept, what do we do for x-intercept?
We do the thing.
We
0 and 4?
plug it in. Y, X.
X-intercept,
kidding,
0
y.
and 4, y. Good,
And then we have to factor.
good. And so what would be the two factors of this?
5 and 2.
Good, 5 and 2.
So maybe plus
One's negative, one's positive.
plus 5. Wait, no. Negative 5 plus 2.
Good, and so what are the two zeros?
Negative 5, 0,
negative
2, 0.
5, 0, and negative 2, 0. Great job, Riley. Great job, Basil. And B-Dub and Ryan. Nicely done.
So, can I get like a cookie for some food?
You gonna get a donut?
Can I get a cookie?
All right, let's go to the back, okay? Let's go to the back.
Oh, you have the colors of flounder on you.
Stop.
Nobody else would have known. Actually, I thought of that too. I should have.
It's flounder.
All right, so here's the thing. 55 and 56, I should be able to just talk you through those to be able to find those, okay?
What's the, oh, those
55 is where we multiply f times g,
Oh, okay, that's easy.
where we distribute. We did one of those in the previous section of the podcast, so if you have questions on those, look back at some of the previous ones on that. Also, 56, we add like terms together. That should be pretty easy. Now, 57, I do want to go through this one. That's 7x minus 9 minus 2x minus 4. Now, I have no idea why we miss this, but we do, okay? In this, a lot of times people will distribute this negative. They'll do that right to get negative 2x plus 4. But then for some reason, they end up multiplying 7x minus 9 times negative 2x plus 4,
No,
right?
You add it.
You can't, right? You can't do that. You combine together, right? Because it's f minus g, not f times g.
So you have to subtract.
I'm subtracting. Good. So it,
So you have
57.
57.
So it's 5x, right? Yeah, 5x.
Yeah, it should be minus 2x plus 4, right?
Yeah.
Yep, so this should be 5x. Yes, because the negative
Oh, the
distributes
yep,
to
you're
both, right?
my bad.
And negative 9 plus 4 is? Good, so 5x minus 5 would be my answer there, correct?
Wait,
All right,
the negative doesn't distribute, so it wouldn't be 9?
no, the negative only distributes to where? The right side, right? It should only distribute to the 2x and the minus 4,
Oh, I should
okay?
Okay, got it.
All right, are we good there?
No, we do that one.
Today?
One like that?
Like 56.
Yeah, I mean, sure, yeah, we would just do 9 minus 6x, right?
There's no Chick-fil-A today.
Plus negative 2x plus 6. So what would be the,
Never mind, I got it.
you got it? So this should, just in case at home you need it, negative 8x plus 15 is what you would get there when you combine them together. Don't distribute. Big thing, don't distribute. Okay.
Plus what?
Plus 15 is what I got.
9 plus what?
Okay.
What number we on? Hold on.
We're moving on. We already did number whatever that was.
All right, that's 56. Let's keep going, all right? Hey, y'all, real quick, I'm going to turn on the jets here, okay? Because right now I'm going to probably put about another 5 to 7 minutes in here, okay? So what we're going to do, I'm going to try to just fly through some, okay? If you have questions, still stop me. Please stop me, okay? Now, let's do number 59, all right? I'll tell you this. 59 is one that I feel like we've struggled with in the past, okay? So we want to make sure we hit on this. So f of x is 2x squared, and g of x is square root of 3 minus x. Okay, so in this example, which one is plugged in for where?
F goes into G.
That's right. So the second one goes in for the first one. The f goes into g. So literally, I'm taking f, and I am plugging it in for the x of the g. Okay? This is 59. Mm-hmm. Does that make sense for everybody?
Mm-hmm.
All right. Go ahead, Dynasty. What's up?
So where does the negative one go?
We're going to bring that in here in a
Bring it in
second.
at the very, very end.
Mm-hmm. This comes
Oh.
in at the end, but for right now, let's do inside first. The f goes in for g.
That's why I always got those wrong. Got it.
Do 3 minus 2x squared inside the.
Yep. So this is what we have. 3 minus 2x squared, right?
Mm-hmm.
Now, a lot of individuals struggle with this because it's like, all right, what do I do from here? If you can simplify, simplify. But in this case, there's nothing I can do, right? I can't take the square root of both and divvy it up because all of this acts as 1. So what I got to do now is I've got to take negative 1 and do what with it?
Put it in for x.
Plug it in, okay?
So that's 2.
So 3 minus 2, not 3. 3 minus 2 times negative 1 squared. So what's negative? We do PEMDAS, right? Okay. Yeah, we got to do negative 1 squared first. Don't multiply first, okay?
Negative 1,
Good. So 1 times negative 2.
negative 2.
Negative 2. So 3 minus 2 is? What's the square root of 1? 1. 1. All right. Be sure not to do 3 minus 2. Yeah, it's perfect now. Thank you so much. Thank you, Mike. And that's how I get 1 then. Okay? How do y'all feel?
I feel well. I
Feel
feel
tired?
well.
Yeah, I hear it.
Okay, man, I'll do it.
I already did all the other ones. Yes.
All right, let's do this one. I'm gonna do 2 more. Okay? Make sure we keep it down. Okay. Let's do 2 more. Let's go 62, and then let's go to 65, okay? 62 and then 65, and that will wrap up chapter 1. Okay?
Have I done those
Welcome,
ones?
ma'am. All right, 62 states f of x equals negative 4x plus 8. We should know how to do this one because we kind of just did it. G of x is 3x plus 5. So what is g of f? What do we do with this one? Yeah, the f will go into the g, right? So literally negative 4x plus 8
3, negative 3.
goes in for here,
3
right?
times negative 4x plus 8 plus 5.
Good. 3 times negative 4x plus 8 plus 5. Okay. So what do we do with 3? To get?
Negative 12x
Plus?
24
Good. Plus 5.
plus 5.
And so what does this turn into?
29. Negative 12x plus 29.
Nice. Negative 12x plus 29. That would be our answer there. Okay. Did I go too quick for that one?
No,
We're good?
that was beautiful.
All right. So let's
We
finish.
have to do one from each section, right?
Two from each section to when you turn it in. When you turn it in. I'm going through one from each section at least. At least.
So like, how can I get bonus points? 'Cause I like did all of them.
I can't give bonus points.
Can I
Sorry. You
request-
can take quizzes.
Can
Those
I
quizzes.
request one?
Okay.
73? Or are you going in order?
I'm trying to go in order. Are you
Okay.
going to be at the Rustic Couch today?
Mhm.
You are. Can we do that then? We'll definitely do. I'm going to do a free for all then.
They have good
So
food.
let's do 65. Is it good?
I'm
excited.
to go. I'm sad.
What are you gonna do?
Let's do the
You're gonna
inverse.
do x equals 2y plus 5 over 7. You're gonna have to switch them, right?
Yeah. So we switch the x and y, right, to where it's x equals 2y plus 5 all over 7, right? So what are we solving for?
Why do we put the y on top? I'm sorry. I'm
You're
sorry.
gonna-
Yeah, this is really like y equals, right? So we want to switch the y and the x
Okay.
Aren't you solving?
and solve for the new y.
Okay.
Right?
Consider that.
That's inverse. That's an inverse.
Okay.
Okay.
Cool beans.
So what can I do to get this new y by itself? Nice. Because this 7's on the bottom, let's get rid of it.
Okay.
So let's multiply by 7.
Then
On both
seven.
sides.
Okay.
These will cancel.
And then it'll be 7x equals 2y plus 5.
Good. So how can I get the new y by itself here? Before I divide by 2. Good. Subtract 5, then divide by 2. So then I get 7x minus 5 equals 2y. How do I get y by itself? Good. I divide by 2 all the way through to where, and again, a lot of times you'll see it this way. The inverse of y, or sometimes f inverse, equals 7x minus 5 all over 2. It's the inverse. So real quick, do you want to see a good way to check this? Okay. You see how in the original, you divided by 5, right? Here, you multiply by 5.
Yeah.
Up here, we added 5, so guess what's going to happen? Subtract 5.
Yeah.
This one, we multiply by 2, we should divide by 2. Now, don't try to just make that up in
So
your head.
Everything goes in a circle.
I mean, yeah, I guess it kind of does. Yeah.
It's such a
But
weird-
don't, I wouldn't do that if I were you.
Everything goes in a.
With that being said, the creepy comment of the day,
Yeah.
everything goes in a circle. And I guess it's the way that Dynasty said it. All right. This is Coach Jay. Holla at me. That really sounded weird. Have a great day. We'll see y'all.